everyone! Today I will introduce you to a 7-inch ESP32-S3 development board. You can see on the screen. The size of this 7-inch ESP32-S3 development board is very large. It is 7-inch 800/480 resolution. Now there's a lvgl demo running on the screen. This ESP32-S3 development board core module is an ESP32-S3 Wi-Fi and Bluetooth module. You can see that the entire module is enclosed in a metal casing. The black printed board above is the printed board antenna of the entire ESP32-S3 module. Wi-Fi and Bluetooth signals are transmitted and received through this printed circuit board antenna. In addition, you can see that this development board comes with an SD card holder. D card can be used for data storage. You can also see this development board has two USB interfaces. This is the USB Mini Type-C interface. Type-C1 interface is USB interface. The other is a USB 2 serial port interface for program downloading. Of course, it can also be used for power supply. In addition, it has an RGB LED light. Can be used to control the light emission of LED lights. You can see two sets of cables on the back. A flat cable is an RGB cable of this display. Another cable is a driver for the touch screen. For the screen, touch and display are divided into two layers. The touch is attached to this display. A separate touch driver can be used to locate the touch position on the screen for an operation. In addition, some GPIO pins of ESP32-S3 MCS led out to both sides of this development board through the PCB board. You can see that there are many digitally numbered pins on both sides. These digital numbered pins are the GPIO interfaces. There are also some powers and grounds. Includes one pin for sending and receiving. Same as the regular ESP32-S3 development board. This development board also has boot and reset buttons. Reset is used to restart the entire development board. Boot is to ground the GPIO 0 pin. After pressing, the GPIO 0 pin is in ground state. Make the development board in a downloadable state. Of course, it also needs to be used in combination with the reset button. Pressing and holding boots. Then reset. Release boots. The entire development board is in a downloadable state. We can demonstrate. We press and hold boots. Then press reset. Release reset. Release boots. Now the development board is in a downloadable state. The entire development board can now download a program. We've downloaded the program. Press reset and restart the power. Start to use normally. The ESP32 MCU of this development board is a module of ESP32-S3. This module has 16 meters flash and 8 M PSRAM. That means it has 16 meters flash and 8 meters PSRAM. Such a configuration is large enough for some common lvgl development interfaces. We can run some more complex lvgl interfaces or other library or portable interfaces on it. The driver IC of this development version of LCD is SAINT7-62. This is a common LCD driver IC. You can find it in many open source projects. Find the relevant driver code of this driver IC. Its touch driver IC is GT911. This combination is also quite common. GT911 is also a very commonly used touchscreen driver. Of course, the screen size of this development board is relatively large. If you only use the ordinary Kaiyuan driver, it will be difficult to drive. It will have a screen flickering phenomenon. No need to turn on Wi-Fi. Directly use lvgl to write the interface. This may cause the screen of this development board to be distorted. Because the screen size of this development board is relatively large, it uses relatively more resources. That is to say, a lot of ESP3 to S3 hardware resources will be allocated to this screen. Therefore, it is more likely to cause screen distortion than ordinary small development boards. So, in the program development of such a large size ESP3 to S3 development board, we found that we needed to use the high-performance Arduino ESP32 SDK. This SDK is also an open-source SDK provided by the official. We will show you some specific explanations of this SDK later. In addition, although this screen can be driven by some third-party open-source drivers, but there is also the possibility of screen distortion. This can cause instability in some programs. So if this screen is developed using Arduino, it is recommended to use ESP32 to display panel, an open-source driver library officially launched by Espressif, to drive it. We tested this library and found that it performs much better than other open-source libraries. For example, we use some open-source libraries to cause screen distortion. But if you turn to this library, the screen distortion will be solved. In addition, if this library cannot solve the problem of screen distortion, then you need a high-performance Arduino ESP32 to SDK to use with it. If these two are used together, they will achieve their highest performance. If these two libraries are used together, and there is still a problem with the screen being distorted, I can only suggest that you use ESP32 for development. The official ESP32 can be said to be the most powerful development kit for developing ESP32 development boards. Of course, the development of ESP32 may have efficiency issues, because the code of ESP32 is more complicated than that of Arduino, requires a lot of C and C programming experience. The code base and the entire ecosystem may not be as rich as Arduino. Of course, it would be better if you could use Arduino for development. Therefore, we recommend that you use the high-performance Arduino ESP32 to SDK plus the ESP32 to display panel for development. Next, let's take a look at these two development kits. Both development kits are available on GitHub. Let's convert. First, we see the ESP32 to display panel library. This library is a library that drives the screen display. It is an open-source library officially provided by ESP32. The overall performance is relatively strong. This library is based on IDF5. So IDF5 support is needed. Of course, if we change to the Arduino development kit, it is the ESP3 to 3.0 version of the SDK. In addition, the Arduino ESP32 to SDK is an upgraded the traditional Arduino ESP32 to development kit. You can see that there are two versions. One version is the 8th version that can output the 8th information. Another version is the high-performance version. It can directly make this SIP run on PSRAM. Of course, this development kit also has some limitations. It only supports these 4 versions. So you need to download one of the 4 versions corresponding to Arduino. Then you can use this high-performance SDK. Let's use Arduino to show you. Here we have already used this high-performance development kit. Now we are using the ESP32-S3 development kit. The open source project just now is actually an upgraded suite plugin. We installed the development kit of an ESP32 development board as usual Arduino. Then install a normal 3.0 version. We now have a 3.03 installed. Then download the contents of the high-performance development kit and replace them. Your Arduino development kit becomes a high-performance development kit. You can use this high-performance development kit to develop. For example, our current 7-inch screen ESP32 development board uses this high-performance development kit. We have developed with Wi-Fi and lvgl on this development kit. This library is a library that drives the screen display. Let's see what the IP of the local area network of the development board is now. No internet connection now. We turned on the hotspot on my phone. You can see. Now we have turned off the backlight of the screen using our mobile phone. Let's look at its address, because my phone defaults to the address just now. Now I re-enter this address to turn on the backlight. 19.168.228.242. Access. You can look at the phone screen. Let's turn off the monitor. The mobile phone screen will display the content of the external server on the current development board. We turned off the backlight. Open it now. You can see that the backlight is now on. We used a high-performance development kit, plus an official open-source driver library, so now the entire development board is very stable. Can be controlled using Wi-Fi. You can see that the screen backlight is turned off again. Open again. Then close. You can see that the operation is relatively smooth. Then the entire lvgl interface display is completely normal. There is no screen distortion or screen drift. The whole program runs smoothly. So use a reasonable development kit. It's also a very clever technique. We introduced this development board here and recommend that you use a high-performance development kit for development. Achieve the best results. Then take advantage of the large screen and the Wi-Fi and Bluetooth functions of the ESP32-S3 MCU. Okay, this video ends here. Thank you for watching.